Assalamualaikum warahmatullahi wabarakatuh. We are from group 3 and our topic for this assignment is about the priority scheduling for the non-preemptive. So our group is consists of two members, which is Nurul Irdina binti Shahrizam and then me myself Nurul Afifah binti Farul Mazhar. So the question that we get is question 3, which is that it given the process name, arrival time, service time, and priority number. And there are 5 processes here. And we have to draw a Gantt chart to illustrate the execution of these processes using non-preemptive priority scheduling algorithm. And also then after that we have to calculate the turnaround time and waiting time for each process, and then the average turnaround time and average waiting time for the system. Okay, now I will show the step by step to draw the Gantt chart for the priority scheduling of non-preemptive. So for this question, so first we have to state that for the arrival time is that all of the process have the different arrival time. Okay, starting with 1, and also here we see that we have 5 process, and then we have the arrival time of the process, the priority number, and the execution time, or also called as burst time. And then here we have the remaining time equal to E3, Et minus E2, Et2. And then here for the Gantt chart, we have execution time, Et2, process, arrival time, and also for the queue. So first is at the time of 0, there is no process that arrive yet. So the arrival time of 0, there's no process arrive. So there's no process that will enter at time 0. Because given here is only arrival time is 1. So because of that, there is no, which means that there's no process at time of 0. So later on, next is at the time 1, the P0 will arrive or enter. Here is the process for this type of scheduling is will be chosen or selected based on the priority, which is that the lowest the integer is, the highest the priority is. However, for this process, which is P0, we choose P0 because of the arrival time for this is much more earlier, which is the earliest one at time of 1. Even the priority number is 4, but the time is the earliest one. So that's why we choose P0. And then the execution time for P0 is 15, which is the execution time is the amount of time needed for the CPU to execute the whole process of. So for this part is for P0. Next is that the P0 will start its execution and stop at 16. So 16 is the completion time for P0. The 1 is the arrival time, which the where the when the P0 will enter at the queue, and then 16 is the completion time. Next one is that at time 16 arrival time, the next process will be chosen with the highest priority or the earliest one. So the process that have been selected is P1, and the execution time of P1 is 14. P1, the execution time is 14. We choose P1 because of the arrival time is here 15, because of the priority number also 2, which is the considered as higher priority 2. And then the P1 will start the execution and finish at 30, which is the completion time of P1. And then at the time of 30, the next process will be selected or chosen with the highest priority. So P2 is being selected because the priority number of P2 is higher than P3. So here P2 the priority number is 1 and P3 is 5. Even both of them have the same arrival time, but we choose P2 because the the number is much more lower, which means that it have much more higher priority. And the execution time for P2 is 30. And P2 will start the execution and it ends at 60. So how we get 60? Because the arrival time for P2, 30 we plus with the execution time, so equal to 60. Also here we have we can, as you can see, here is P3 and P4 queuing under here because of the arrival time of P3 and P4 is 20 and 25, which is less than 30. So it will be queuing under this part, but it will not be chosen or selected yet for this part. And then at the time of 60, the next process will be selected. So the next process being selected is P4 because of the priority number. If we compare with P3, P4 with P3, the priority number is for P4 is 3 and P3 is 5. Even the arrival time for P4, if given here, is 25. But we will look at the priority number, which is 3, much more higher priority because of the lower integer. So we choose P4. And the time execution of P4 is 5. And P4 will start the execution and stops at 65. And then at the time of 65, the only process that left is P3 because the other process already been done as the previous before. So the only one left is P3. So the execution time of P3 is 10. And then P3 will start the execution and will end at 75. 65 we plus with 10, the burst time and the arrival time of P3, so equal to 75. And at the time of 75, all of the processes are completed. So here is the completed Gantt chart for this question, and also the remaining time here are all 0.
Hi, my name is Nurul Binti Sharizam. So I'm going to explain how to calculate the turnaround time and waiting time for each process, and how to calculate the average turnaround time and average waiting time for the system. So as you can see, the purple one is the formula for turnaround time, which is completion time minus arrival time. As you can see in the table below, 16 minus 1 will equal to 15. 16 we got from the completion time and 1 we got from the arrival time. So equal will be 15. 30 minus 15 will be 15. 60 minus 20 will be 40. 65 minus 25 will be 40. 75 minus 20 will be 55. So to get the total turnaround time, just add all the turnaround time and you will get the real total number for turnaround time, which is 165. For waiting time, this is the formula for waiting time, which is turnaround time minus burst time. 15 minus 15 will become 0. 15 we got from the turnaround time, and another 15 we got from the execution time. So 15 minus 14 will become 1. 14 minus 30 will become 10. 40 minus 5 will become 35. 55 minus 10 will become 45. And the total for the waiting time is 91. So to get the average turnaround time, the total just divided by the number of the process. So 165 minus 5 will become 33 MSec, and for average waiting time, 91 divided by 5 will become 18.2